So now that you've mastered the position versus time motion graph and also motion diagrams, let's take a look at how to interpret and analyze velocity versus time motion graphs. So to start this, what I'd like you to do is take out a blank piece of paper and make a big set of axes right in the middle of the sheet. Offset them a little bit off to the right like I've done here, and let's take some notes. So for velocity versus time graphs, what do we need to do? Well, let's start by labeling the axes. Of course, we're going to have a time axis, and let's use MKS units for this example. And then for the vertical axis, we would use velocity in the x direction or the y direction or perhaps the z direction. And our units are meters per second or feet per second if we're using MKS or US customary units that are relatively small units. Of course, time starts at 0 on the left side of our axis right near the origin, and velocity is 0 meters per second at the origin as well. And of course, what does 0 meters per second mean our object doing? Well, the object is stopped. So in other words, if I had a point right here that I was plotting, that would be an object that stopped for that one moment in time. Of course, we all know that in driving a car, we don't stop for one moment in time unless we want to get a traffic ticket at a stop sign. If we wanted to stop at a stop sign without getting a traffic ticket, we'd stop there for a bit of time. So here we are stopped at 0 meters per second for a period of time. So on a velocity versus time graph, you're stopped for a moment or for a period of time when you're on the t-axis. All right, our height of our points plotted is at 0 meters per second. We're looking at this axis here as a velocity axis. All right, so moving on. So up in this area, we're in positive velocity area, anything above the 0, and down below we're at negative velocities. So what does that mean? Well, for positive velocities, that means we're going forward if we're talking about the x direction, or upward in the y direction. So any part of our graph that's up in this region means the object is moving forward or upward, depending on x or y. Here's another shape that could be on our graph, and notice the difference in shapes. I've got a curved section versus a straight section. The question for you is, how do you interpret those two different shapes? I'll leave that for you to figure out. In the same sense, anything down below the 0 meters per second in the lower part of our vertical axis represents negative velocities. So anything down below here means that something has a negative velocity, which means we're going backward or we're going to the left. And so we could have all sorts of shapes down below here. So once again, the big idea here is that anything in the positive velocity zone, which is above the time axis, represents an object that is moving either up or forward, depending on if you're talking about your y direction or x direction. In the same sense, anything that is below the t-axis has a negative velocity. Of course, negative velocity means we're either moving downward if it's the y direction, or left or backward if we're talking about a horizontal x-axis. Of course, there's several questions that we could ask about this thing. This is what you're going to have to figure out. How do you interpret the slope? Of course, the way you're going to interpret a slope on any type of graph is to draw a little slope triangle and write down m equals rise over run, and go ahead and start plugging in your vertical and horizontal variables to figure out what that means using dimensional analysis. In the same sense, we can interpret the area. So you can draw yourself a block of area, write down a simple area formula like area equals base times height for a rectangular area. Go ahead and plug in your variables and see what types of units are there, and do the dimensional analysis and see what Other questions you should be asking yourself is, when you look at these graphs, how do you find your initial position and your initial velocity? And then how do you find both average and instantaneous values for your position, velocity, and acceleration anywhere on the graph? Finally, we had some of these interesting questions about whether or not cusps, these pointy parts of the curve, are realistic. And we've actually got a couple more cusps right here and right here. And we could also ask ourselves, what about a discontinuity like this jump we have going from a positive velocity down to a zero velocity, it looks like here? What would we do in that type of situation? So that's another question I'll leave to you to think about and answer. So what I want you to do for your homework is to go back to these handouts that I gave you, and you'll recognize this handout we've done with the position versus time motion graph. Now I want you to use the concepts that I just reviewed to interpret each one of these 5 graphs. What is described in the motion mapped out in each one of these diagrams? And please write those in a sentence, perhaps down below each one of these motion diagrams that you're going to try to create. And what I'd like you to do is then go ahead and try to work out from these motion graphs. Do you need any assumptions? What is the physical meaning of your slope and area using the techniques that we know how to use? And then see if there's a way that you can work out your positions to work out a motion diagram for each one of these graphs. So as you're working through these worksheets with a friend or two, I want you to think about the 12 key questions for the velocity versus time graph that I've outlined for you. I've already gone through a few of these, but take a look at what you're doing and see if you can fill in the answers on these with a little bit of... And please, when you're answering these 12 velocity versus time questions, what I'd like you to do is perhaps up in the upper left-hand corner here, draw a representative graph so you can point out a few of these questions on that representative graph. So here's another worksheet that I would like you to work through, and this is something you've done before as well. I've given you, this is the first page, and this is the bottom half of the first page. The second page of this would be the 12 little graphs you've already seen for position versus time graphs, as I mentioned up here. Now what we're going to do is you're going to go through an exercise. What would happen if I took that same position graph and just looked at it in terms of velocity versus time rather than position versus time? And you can start by interpreting these two. Refresh your memory on what this graph meant, and then reinterpret for this graph. Start by writing a sentence for each of these. And then I want you to think about these big ideas here of what does the physical meaning of slope and area for each one of these graphs means, and make yourself a nice little summary. Then go through the process of answering these questions, and these are the exact same questions, almost identical at least, for the questions you answered as if it was a position versus time graph. Now you're going to take a look at those 12 little graphs and see which of those represent each one of the motions as if they're velocity versus time graphs. Once again, the most important part of this worksheet is to tell me how you came across your answer, not the answer itself. And please don't say, I just looked at the graph. You need to tell me what you saw on the graph that leads you to these conclusions. I've also given you a review sheet of position, velocity, and acceleration versus time, what the slope means, what the area means for each. Please show your dimensional analysis and write yourself a few notes, and we can draw some representative graphs on the side here. Finally, I've already asked you to do parts 1 and 2. You found that this worksheet looks very similar to a former worksheet we've done. And parts 1 and 2 should have been quite easy. We've already done these types of things. But now I want you to think of how you would do part 3 and go through and finish up part 3. And here's a little something to help calm you down and focus on your homework.